So we got a block of wood that measures 10 centimeters by 20 centimeters by 4 centimeters. I'm going to attempt to draw that in a sec. It's floated on a pool of water. And it's submerged to a depth of 1 centimeter, right? So when you throw things in water, sometimes they sink, sometimes they float. When they float, usually part of it's underwater and part of it's above water. So they're giving us that scenario. Then we put 50 grams on top, and the depth becomes 1.25. We put another 50 grams on top, and then the depth becomes 1.5. All right, so we went with a depth of 1 to 1.25 to 1.5. And we want to find a linear model for the depth in terms of the mass. So that means the depth is my y and the mass is my x. Okay, let's start writing some stuff down and making some pictures. Page. And I'm going to copy it so I get the relevant information. All right, so we've got a block of wood. It's a piece of green wood, and it measures, it's 4 centimeters tall, so that can be my 4 centimeters there. And then it's 10 centimeters, say that way. So let's see, if that's 4, that'd be about 10. So this is the 4 by 10 side, and then it heads back this way, 20 centimeters. So maybe this is what my block looks like roughly. So there's 10 centimeters here and 20 centimeters that way. And it is floating, so let's see, and 1 centimeter is submerged. So that's 2 centimeters, so 1 centimeter would be about this high. So this part of the block is underwater. Let's get some water in the picture here. So here is my water. It's floating in there. So 3 centimeters is sticking up, 1 centimeter is down. All right, so next I'm not going to redraw for this other information. I just wanted to get a feel for what was happening here. Yeah, and so if we put weight on top of the block, right, it's going to sink into the water. And eventually we could put enough weight that it would just stop floating, right? It would go underwater. All right, so find a linear model for the depth in terms of the mass. So in terms of means this is going to be my independent variable, and this is going to be the dependent variable. And that kind of makes sense because I'm putting weight on and I'm watching what happens when I put weight on. So the depth this thing sinks depends on how much weight we have, right? Remember the whole independent, dependent variable thing. So mass is my x, and they're saying call that W for weight. And then the depth here is my y, and they're saying use D for depth. And what are the units? The units are grams for mass and centimeters for depth, right? Yep. Okay, so similar to the previous problem. So the block of wood on the water is acting like a scale, just kind of like the spring does. So if there's no mass, then we get a depth of 1 centimeter. Right? We didn't put any extra weight on there. Then they put 50 grams on top, and the depth is now 1.25 centimeters. And then they put another 50, so that gives us 100 grams total, and the depth is now 1.25. Oh no, we already got to 1.25, it's 1.5. All right, so if you haven't already, I would highly recommend you write down this same table that I wrote down because you're going to need it to answer question 5 and the next couple of questions. And then I'm going to actually put you guys into groups to make sure you guys can agree on the answers to the next few questions, and then we'll regroup, talk about them together.
Yeah, I had a problem with that because I didn't do the, I didn't start with a 0 and the 1 first.
Yeah, noticing that no, right, because the block's just sitting there with no extra weight. And if you make that observation on how to use this 1 here, it makes this problem way easier.
Right.
Yeah, and you can do it without that, it turns out, because you have 2 points here and here. And why am I drawing with the mouse? We have 2 points here and here, so those points are actually enough, but this extra point makes it much easier. Okay, so let me get the group set up here. Where's my group button? There it is. Let's try that. Looks good, looks good, looks good. Okay, so I'm gonna open up the rooms, and what I want you to do once I open up the rooms is use that table we just developed based on this information to answer questions 5, 6, and 7. And 7's the hardest one, I think. So be prepared to struggle with that one and debate it a little bit. All right, go for it. I'll come check in on you in a minute.